Okay, we have a square field measured 10 meter by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side length of 1 meter, and no two regions overlap. The student count the earthworm containing the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Okay, so we have this table. A, B, C, D, E, F, G are all 10 regions and the number of earthworms in each region. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Okay, and 150, 1,500, 15,000, 150,000. Okay, so for this question, we kind of have to, understand see the big picture here, right? What are they trying to do here, right? So this is a little bit confusing. Just to trying to understand what's going on here, right? If you look at the table, all these numbers, you can definitely add them up and divide by 10. Or if you just kind of look at them, seems like the average is about 150, okay, more or less. Okay, it's about 150, and it matches with all the integers. It seems like we all have it's all related to 150 or something similar. So the average here is about 150. Okay, we just kind of look at it as around 150. But we had to understand what is actually going on with this experiment, okay, and what are they trying to ask us. So what happens is we have a square field, right? So it's a square. My drawing is not perfect, but okay. Let's just say we have a square field and we're dividing this. This is 10 meter by 10 meter. Okay, so it's like 100 square meters for the area. And we're dividing this to little square regions, and the side length is 1 meter, so it's 1 by 1. So if you think about this, we'll divide it into 10 rows and 10 columns, right? So we're not going to draw everything out, but okay, so 10 rows and 10 columns, you get the idea, right? So then we should have 100 little regions inside. Okay, 10 by 10, the total is 100. Right, so we pretty much have 100 regions. And we want to know what's the total number of earthworm. Okay, we're going to estimate that, okay, in that 100 regions. We could, dig all 100 regions, right, and dig them up and count them and average that number. But that will be very time consuming, right, and it will be very costly. So what they did here instead of measuring all 100 regions, we're going to pick randomly, we're going to pick 10 regions out of the 100, and we're just going to count the number from these 10. Okay, so it's similar to how we do like a survey, right? So to say something about the whole entire population, right, is sometimes not feasible to ask everybody. So we're going to pick a smaller sample, right? So it's like a sample design here. So pick a smaller sample and we use that number to apply to the whole population. Okay, so based on our own small sample here, we see the average for each region is about 150, we said. Okay, but keep in mind that's just one region, right? So 150 is the average for each region. So since we have 100 regions, the total we do have to multiply by 100. So we can do 150 times 100. That should give us a total number of earthworm in the entire field. Okay, so if we do that, multiply 150 times 100 is 15,000. Okay, 15,000. That should be our final answer, which is C for number 27.